Oh, hi there. Thanks for showing up for your learning. I do appreciate everyone's attendance and presence and awareness. We're going to use these trigonometry skills and put them together in 3 dimensions today. It's funny that we get one day on this topic because really our trig unit is a warm up for our next unit, our trigonometric functions, which is to me the centerpiece of the course. It's a really useful, really powerful unit coming up. And this is kind of an offshoot of that. It's not really preparing us for next unit, but it is showing you how trigonometry can be used in the world as trigonometry and with triangles in 3 dimensions. So we're really going to work our diagram making muscles today, as well as your imaginative muscles, being able to imagine these situations clearly and create great diagrams that you can apply that you can get your trigonometric equations from is the main thing. So the steps to solve here, let's go through these. Oh, these are in your package as well. All the work for today is in your handout package, so in trigonometry and 3D. If you don't have a package, I have a couple extras still on the desk, so maybe go grab a couple extras there. So the first step is drawing a labeled diagram. Okay, draw a diagram, label it. As you turn unknowns into knowns, I would recommend putting those known numbers into your diagram, labeling the common sides all the same. So what I do here is a little different than what this person is describing. I draw a 3D diagram, and then I explode that into various 2D triangles. What's a triangle? It's a shape with 3 sides. Parallel. Oh, two skis, keep them parallel if you cross your skis. Yeah, okay. All right. So then we're going to decide on a method to solve it. So once you have your diagram, you're going to look at the triangles that are in there. You're going to say, where do I have the most known things? Start your work from the most known things and work towards unknown things. You need 2 things known in a triangle to solve other stuff. You need an angle and a side. You need 2 sides in an angle. You need a right angle, an angle, and a side. You kind of need like 3 things to solve the other 3 things. Okay, so and that's going to be just going through your flow chart from the last day. You're going to do SOHCAHTOA if you can. You're going to do Pythagorean theorem if you can. Use sine law if necessary. Use cosine law as a kind of last resort. All right. Once you solve the problem, great. Congratulate yourself. Give yourself a pat on the back. And then don't forget to write a sentence answer. Okay. So cardinal directions here. We start at 0 degrees up there at north. And then this would be like a certain number of degrees east. We would probably do that as positive numbers of degrees east. Positive degrees east. And this would be positive degrees west. Yeah. All right, so let's go ahead and take a look. The 2 examples that I'll go over with you are the first one here. Very similar to this problem, just in the problem the way I asked it over here, I removed some of the ambiguity. In order to answer this question that we're looking at here, example 1, you need to know that you're first looking square at the cliff, or your first measurement, and when you walk to a different point, that point's parallel with the line of the cliff. Those are important pieces of information. So let's go. First thing we're going to do is make a diagram. So we have an inaccessible cliff. Let's draw our cliff in black. Okay, here's the top of it. Here's the bottom of it. Why is it inaccessible? Oh, I decided that there's a river going along there. So we have a river along here, represented by that sine wave. And then put yourself into the problem with your imagination. This really will help your solving of these. Put yourself down here at point A. Okay, so to determine the height of this inaccessible cliff, the surveyors recorded this data from point A. So put your point A down there. Label it. The angle of elevation to the top of the cliff was 38 degrees. So we go over here to the cliff, and I just draw that on a bit of an angle. That's looking square at the cliff.
Isn't the bottom of it?
Yeah, that's the bottom of the cliff. and then this is climbing the cliff to the top of the cliff. If I come down to make a triangle here, notice that triangle is like tall and this way, and I'm looking at the cliff in my diagram. So that's why this angle looks very narrow, but actually it's 38 degrees inside there. Okay, and then we go to a second point, B. So let's put this point B over here, parallel, walking parallel to the cliff. So this line and this line here to point B are parallel. And we know that that's 68.5 meters. All right. So when we look back, the line of sight between point A and the base of the cliff is 42 degrees. So meaning if I look from B all the way over to the base of the cliff where we were taking our initial measurement and looking back at point A, that's 42 degrees there. Okay. Notice that we want to know H, the height of the cliff. And inside this triangle, if I explode this, we've already got A and B, so let's add points C and D. If you don't know, if you're not given the name of a point on a triangle, give it a letter. All right? And now we can explode these triangles out. And I have my triangle here, ABC. So let's draw that. It happens to be a right angle here because this was square to the cliff, and so it's going to be square over there because those are parallel. All right. So here is ACB. So I draw a second diagram with this triangle, and so here is point C, here is point A, and here is point B. This was 68.5, and this is 42 degrees. Notice that that triangle, I have three pieces of information: right angle, another angle, and a side. I can solve the rest using SOHCAHTOA.
How do you know that that's a right angle?
Yeah, how do you know A's right angle?
How do you know that?
Because I said that I'm walking parallel to the cliff.
How do you know that it originally was a right angle? You're looking right
I know
at.
three's right angle.
Oh, so I had to make a couple assumptions to make this question work, and I kind of tidied it up when I asked it over there on the sideboard. I'm looking square at the cliff to find that it's 38 degrees of elevation above me. Okay. And I have to be looking square at the cliff. If I look down at the cliff like that way, it's kind of like the elevation is going to lower, right, as the cliff goes towards the horizon. And then here it's going to be a maximum, and there it's going to lower. So I think it's a natural assumption to make that the surveyors look square at the cliff and find that. So I had to make that assumption. I've already kind of stated I made that assumption.
The longest line is where you're
Put that
looking.
square.
The longest line is where you're looking, and the line that leads to a right angle is like the shadow of your line, or the shadow of your sight.
Yeah.
Yeah.
So I'm square to the cliff, and then I look
That's
up.
just showing that you're square.
So
Okay.
it's just right angle to be.
And then for this to be useful, the surveyor walks parallel to the cliff, and then measures this angle there, because that allows us to create this triangle where we can calculate the distance across the river.
Oh, I understand now. Yeah.
So this triangle ABC is going to allow us to calculate this measure here. Let's call it little b because it's opposite angle B, and then put it on your diagram. That's B over there. Okay? That's going to allow us to calculate that side. Once we've done that, we're going to use that for triangle ACD. ACD looks like this.
Yeah.
A right angle here at C, and then the top of the cliff D. We're trying to find height, and we'll need base there because all we have in this one is a 38-degree angle. That's all we have. We don't have any side lengths. So you can imagine if the cliff was really, really far away, it would be very, very tall. If the cliff were very, very close, it would be very, very short. So we need to know how far across the river is, but it's inaccessible. So we needed to create a second triangle in order to measure that. So let's first calculate the first triangle that's solvable and work our unknowns, work the new knowns into the unknowns of the other triangle. So let's go.
Use coast and use adjacent over adjacent.
Here we can use tan.
Oh wait. Oh yeah. Sorry,
Yeah. Opposite over adjacent is tan 42. So we'll write that down.
Oh,
Tan 42 degrees equals B over 68.5, multiplying both sides by 68.5. I did this in the morning and I forget the values. 68.5 times tan 42 is B, because this cancels. Multiply by something you're dividing by, it cancels.
How many decimal points?
1.
61.7.
So 68.5 times tan 42 is 61.7. Yeah, I remember that. 61.7 equals B. Circle it. It's a new known. Put it on your diagram there. 61.7. And also compare it to your guess. Why does that make perfect sense that it's just slightly shorter than that?
Yes, you stayed square.
Huh?
Because
Isn't it high for high values?
Well, this angle here, if that were 45, what would you expect that would be?
large. Yeah, no, wait.
Be the same as
It's
that.
gonna be the same. No,
With 45 degrees, that'd be a nice isosceles triangle. That would also be 45 degrees, and these two sides would be the
You
same.
would have to be closer for the angle.
So that would be 68. Because we trimmed off a few degrees, we trimmed off a few meters as well. Okay, so that should make sense for our guessing muscles. Now, we can transfer that new known over there. I'll keep it in this color to remind us where it came from. This is now 61.7 here. Now we can use tangent again. Yeah. So then we have tan 38 degrees is equal to opposite over adjacent, height over 61.7. Multiplying both sides by 61.7 gives us h. So calculate that. 61.7 times tan 38. This expression here, 48.2 meters equals h. Circle it. You can put it on your diagram. H equals 48.2. Check it. We're looking across. We're looking up at the cliff. It's 48 meters tall. Cool. All right. This was 68 meters. That was 61 meters. Yeah, it all seems to make sense. So the last step is to say, therefore, the cliff, the beautiful cliff, is 48.2 meters tall. The real trick is creating your diagram. The next trick is working from where you have the most knowns towards the most unknowns to find your desired unknown. The diagram comes from imagining the situation and labeling all the things that are inside the question onto your diagram. This is a very important step in the problem. Let's look at another example. So from the top of a 50-meter bridge, okay, when I'm going through a word problem like this, I might highlight these types of things, like a 50-meter bridge. That's an important thing. Oh, we're going to have two boats. I bet. What are we looking for? We're looking for how far apart the boats are. Okay, one boat. Well, what should we call this boat? George? Okay, boat G. And then the other boat? Second boat? Fernando. I was thinking F as well. Fernando. So it's George and Fernando, and they're both boats, and they're both viewed from a 50-meter high bridge, and we're looking down at both boats at different angles and at different bearings as well. So let's get a good diagram. We're going to use a black color for the bridge. Here, this is how you draw a bridge, everybody. It's a parabola with a negative a value, okay? And then put yourself on there so that you can imagine yourself looking out. Maybe you imagine like the beautiful sunset coming this way and it's dancing on the water.
So that's 50 meters tall.
Yeah, and that's 50 meters tall. So I'm going to draw the water line is here. Okay? And then all this is water. This is horizontal surface out here, okay? And the height here, if I go down, it's useful to remember that that makes a 90-degree angle. That's 50 meters. We're 50 meters high. And then there are two boats. One is seen at south 50 degrees west. So right now we're looking south, like I'm looking north at this picture. The person on the bridge is looking at me south. Okay, so this is south this way, and this would be then east, and this is west. And those are the directions we need for this problem, but let's finish our compass rose north. Okay. And now, well, let's put our boats in. South 50 degrees west. So 50 degrees west would mean it's not perfectly south, but it's 50 degrees from that this way. So more west than it is south, like that. Out here is boat G. So label it. There's boat G out there. We can draw a boat.
And that's 50 degrees going off of the x-axis.
Have fun drawing a boat.
Why
No,
isn't it
that's
going off
50
the
degrees from south.
Why isn't it going off the person? Like 50 degrees from the person.
But it also is going off the
It
person.
is going off the
Because I'm looking down here. This is the angle up to the eye line, right? Up to 50 degrees. And we are looking down at 38 degrees. Okay. So if we're looking down at 38 degrees, I want to show you something. If a plane or a bird or a something up there, that's the horizon line and that's the ground line there. Okay. All right. So here's us at the top of the bridge looking down at 38 degrees. Here's the boat down here, and it looks up at us at also 38 degrees. They're the same.
The angle of elevation is equal to the angle of depression.
Yeah, because the horizon line is parallel with that line, and that makes Z pattern.
Oh, it's like, oh yeah.
People remember Z
I
pattern?
remember that. But the
Yeah.
angle of depression is the.
So those angles in the corners of the Z are the same. So if I look down, something else is looking up at the same angle.
But the angles on the left side of the dotted line, not on the inside. If
Yeah.
you see the dotted line where the person is, it's on like the outside of it. It's like the angle.
Where? You mean in my other diagram, this
Yeah,
one?
It's like right.
Yeah.
Alex, you wanna go
I don't want to draw the horizon line like coming out here because it'll be too weird. But if you can imagine, this the
yeah.
solid line down there is along the water.
So,
It's square.
yeah.
That solid line is square with the
Yeah.
the vertical line
Yeah.
because it's horizontal and vertical
Yeah,
are
it's like-
always
it's like-
square.
it's
Doesn't
like-
matter which angle this
You
is.
have it drawn like this, but in reality, it's like this kind of.
Yeah.
Because he's looking.
And then this is 38 degrees, right?
Because
We said 38 degrees.
He's looking this way, but the boat's going this way.
And has an angle of depression of 38 degrees. Yeah. Okay. So the second boat is at south 60 degrees east. Oh, we forgot to label this. This is 50 degrees off of south. And then there's another boat over here. Let's do another color. Yeah, it's weird, but it's right angle. And the reason is, I'll try and show you in the video. Like if I make a right angle like that and I rotate it, it's still a right angle. So there's an infinite number of right angles that I can make because there's an infinite number of rotations. And so that's a triangle that's like there. This is the vertical. This is along the water, and then I rotate it that way. It's still a right angle in that corner. It's still a horizontal with a vertical.
We didn't tech class.
So this next one is 60 degrees this way. 60 degrees, and it comes out like that and goes out to boat Fernando. There's for boat George and boat Fernando. Draw Fernando's boat. Okay. And then we'll just draw us looking at that from up there. And then what we're looking for to solve this problem is the distance between the two boats. So we can put that on and call it, let's call it D for distance. Okay. And we also know something about this angle here. That was a 35 degree angle of depression. So this is 35 degrees in here.
That's hard.
Yeah, it's hard to draw these diagrams. That's why I recommend, I'm not much of an artist, as you can tell. So that's why I recommend draw your 3D diagram to organize all your knowns and unknowns.
Right angle.
That's good.
Right angle there.
No. No, there's nothing telling you that's a right angle.
You're going straight down the middle though.
And then
Wait, the other one?
and then explode your 3D diagram into 2D triangles. Okay, so now we need to label some corners here. Let's call this corner down here D, where the bottom of the bridge is, and then the top of the bridge, we'll call it B for bridge. Okay, and so now we've got 3 triangles that we're going to need to work with this problem here. Okay, and I'm just going to erase this little explanation there. Gone. And then to find how far apart the boats are, we're going to need to solve this triangle. DGF. Okay, there's D, there's G, there's F. The only thing we know about this triangle so far is that this is 110 degrees. How did I know that was 110 degrees? 60 plus 50. Yeah, I can see it in this triangle there.
Yeah.
My desired known, the desired thing I want to know is this distance D here. I don't have any lengths in there yet, so I'm going to have a lot of trouble finding that. I'm going to need to know this length and that length to find it. Okay, now I also have triangle BGD. So let's draw a triangle BGD in another color. We'll use forest green. BDG is there. It's a right angled triangle because it's a horizontal line and a vertical line. And so this is 50. This is B. This is D. And this is George. All right. And we know this is 38 degrees. We don't know this distance, so let's call it a little b. And we can actually put little b on that diagram there because it's a shared side. Cool. And now there's one more triangle we're going to have to wrestle with. I'll draw it in here. The other triangle is BDF. So I'll draw it over here. This one was 35 degrees. This is F. This is D. And this is B. And this is a different side length. We also know that the same height is there because that's a common side, BD and BD. And we'd like this height there too. We don't really have a letter that's free, so let's use A. And then we can put those on our diagrams as well. This is side A there, and this is side A over here. So I took these three triangles and drew them in 2 dimensions each. Now I notice this triangle and that triangle are both solvable. I have enough knowns there. I have the right angle, I have another angle, I have a side. So those are solvable triangles. Let's go. So let's solve for B. Let's use four-screen. Tangent of 38 degrees is equal to opposite over adjacent. 50 over B. Can I rearrange that in one step, or do you want to see all the steps for isolating B? Prefer to see all the steps. Okay, let's do it. So
just divide 50 by 10. 10
yeah, you multiply both sides by B. And then that's annoying because we got B times tan 38, and we just want to know B. So we also divide both sides by tan 38.
64.
Okay. And so here are our cancellations that we get. Some delightful cancellations happen. We are going to cancel tan 38 and tan 38 and tan 38, leaving B alone on that side. So B equals 50 multiplied by B divided by B. So those B's cancel. So that's 50 divided by tan 38. And Ben, you had that?
Yeah, I got
64?
Should we go to triangle BDF and solve for A?
So that's 64. So put it on there, 64. And then we can put it over here. Instead of B, that's now 64. Let's go ahead and solve for A now.
Is it BGF and not BDF?
That was BDG, yeah.
BDG.
BDG was this triangle here.
That's what
And
we
then
found.
BDF, we're going to do BD and Fernando. So this one works similarly. Tan 35 equals 50 over A. Multiply both sides by A and divide both sides by tan 35 gives you A is equal to 50 over tan 35.
Wait a second. Why didn't we already find B? Why are we solving for A?
We're solving for A, so we get this one here.
Is that but that's the corresponding side with angle B.
Huh?
Do you see how side A is corresponding angle with angle B?
It's a different angle in both triangles.
Is it?
It's a different angle over here. Because this was the first triangle that we did.
Yeah.
Okay. And now we're doing this triangle.
That's right. And we're solving for.
They're different. So we labeled the sides different because they have different angles. The angle B is not the same on both sides. Angle DBF over here is different than angle DBG over here. They're different. Okay. And so we get A is equal to 50 over tan 35. So what's that? 50 over tan 35.
Opposite over adjacent. Right?
Yeah. 50 divided by 35, but I take the tangent of it. Equals 71.4. So A is equal to 71. That'll be fine. So there, we've got two unknowns that are now knowns. We can put those onto our diagram. This is no longer A, that's 71. And then we can put this no longer A, that's 71. Now this triangle up here is now solvable because we have side angle side, right? 64 is one side and 71 is the other side. And in between them, an angle of 110.
So it's cosine.
So this will be cosine law to solve for this
So
one.
so we're gonna. I guess that's just A squared equals. Was it?
We're going to do D squared
Oh yeah, sorry.
is equal to 64 squared plus 71 squared minus 2 times 64 times 71 times cosine of d. Oh, and d is known. D is 110. So let's just put in 110 instead of d there. Oops. Cosine of 110.
54 squared plus 70. Oh, crap.
Yeah.
So,
I had some trouble punching this in the morning. The calculator was not cooperating. I was a little surprised. So let's see if I can get this calculator to cooperate. 64 squared plus 71 squared
12,000 makes sense or no?
minus 2 times 64 times 71 times 110, but I take the cosine of it, equals. That looks good. Did you have 12,000 something?
All right. Oh, yeah, from the square root.
12,245. Was it 0.7 or something?
110.7.
0.2, yeah. Okay, and then we are going to square root that, and it's 110.7, so 111. D is equal to 111 meters. Cool, cooperator cooperating. Calculator cooperating. So that's how you do it. No. Yeah, the easier way would be to have one boat use a laser measure at the other boat and then just measure it directly.
I think she means using
But maybe we're a super spy, and we want to know if the blast radius of the explosives we planted on George's boat are going to harm Fernando in his boat. Maybe we do want that to happen. We don't want that to happen. We want to know, is it safe to push the button yet? We got a lot of calculations to do. We can't just ask them to measure because then they get suspicious. So, the first question is really challenging today. Two roads intersecting at 34 degrees, okay? I would recommend skip that one and come back to it because I'm bored of talking about it, and there's lots of questions for you to talk about today. I talked to everyone in the morning about that question. So, try a different one.
Okay, kid.
Try the other
Let's
ones.
try the last one.
Read through the questions and visualize them and find one that you want to work on. There are 7 questions there for you and 7 answers here, and go for it. Oh, and in the first question, it's not a helicopter. It has to be a UFO because it's like kilometers up in the air. And any questions, hit me up by email. Bye.
That's
a good one, bro.